Okay, this is going to be just a short little podcast to go over what to expect on the test. I know I usually do this every day in class before a test. I'm not there today, so I want you to make sure you have the same opportunity. So let's go through your packet. On the first page, yes, you need to know the history. Let's see, let's first kind of go over the test. 15 multiple choice, so I guess actually 16, I believe, for the district test. Lots of concepts on this one. Then on my test, you still have another 15, so that's a total of, I believe, 31 multiple choice. Then you will have a short answer. Then there are arranging elements, just like we did in that bell ringer. I'm going to give you a list of elements, and you're going to either arrange them in increasing or decreasing, and all 4 of the trends will be used. And then what else? Let's see, we're going to look at some size of ions, and then you are going to just use some clues to find elements in the periodic table. So lots of concepts. Let's start on page 2. Mendeleev, yes, very important that you know Mendeleev. Know that he used mass. Not sure I like writing with a highlighter. Maybe I'll change that. That's very important. Periodic law, yes, you need to know it. Recognize that what makes up a period. It's made up of all the different elements at an energy level. Do you need to know your groups by name? Yes. You need to know their reactivities, meaning alkali metals are the most reactive. Alkaline earth metals are very reactive, but they're not as reactive as alkali metals. Halogens, extremely reactive nonmetals, the most reactive nonmetals. Noble gases, very, very stable. Why are they so stable? Because they have that full octet, or that full outer shell of electrons. Remember, they all don't have 8 because we have helium stuck over here, and it's acting like a noble gas because it has that full outer shell of electrons. As far as this, just being able to recognize, let's go on down the blocks. Kind of recognize what kind of elements are in it. In the S block, there's just metals. That P block is the weird one. And on a periodic table, if you kind of look at it, let's see if we can draw. Yep, nope, can't draw. That hasn't changed. We know that's the periodic table. We're going to go with it. P block should be much bigger than that. There we go. On this P block, look at what happens. This is the most metallic part. These are your nonmetals. So what happens? They become more metallic as you go down, or they're less metallic as you go across. So you can also talk about metallic properties and just kind of use your common sense. So you know these are the metals, these are my nonmetals, so you can see if they become more or less nonmetallic if you just know where the elements are. Definitions: metals, nonmetals, metalloids, where to find them. That's always good to know. Nuclear charge. Yes. That is, remember, the charge of the protons is how many protons in the nucleus that those electrons are feeling. Shielding, not as much. Main group elements, remember this is just your S&Ps. Definitions, yes, you need to know the definition of an atomic radii. You need to know these trends. This is where you're going to have a list of elements. So atomic radii are definitely something you're going to see. This down here, when I said ion size, yes, you absolutely need to know this. How does the size of a cation compare to a regular atom? How does the size of an anion compare? Remember, just think of it, if you're gaining electrons, they're going to get bigger. If you're losing electrons, they're going to get smaller. You need to know what kind of elements make metals and what kind of elements make cations, which are metals, and which kind of elements make anions. Those are your nonmetals. Ionization energy. Know the definition. You need to know the definition. You need to know the trends. You're going to get a list of element and ask to put them in the correct order. Transition, don't worry so much about those. Okay, this part, remember we said once that noble gas configuration is reached, It takes a very large amount of energy. What you just really need to know is remember that each time you try to remove an electron from the same atom, it's going to take more and more energy each time you take away an electron. Okay, these worksheets are very, very, very good to go back and practice on them. They're very good to make sure that you know how to answer this. This is a lot of times where we get the sources of those questions, going through them. Okay, then we had our two other properties. Electron affinity, it's kind of like the opposite of ionization. Remember, it's the energy released. And then electronegativity, this is the talking about electronegativity. It's the ability to who can steal or who can attract more of the electrons in a compound. You need to know these definitions. Remember, both of the properties with the electron in it, fluorine is the highest, and it helps you with the trend. If you just remember the one with the electron in it, fluorine really, really wants everybody's electrons, so fluorine is the highest. Noble gases are not part of the trend. You need to remember that. Okay, so as we go through our trends here and we summarize the trends with the arrows, arrows are awesome, but you need to remember the why. And so the why is you go down a group. We did that POGIL activity. If I ask you why you see a trend of a radius getting bigger, well, first, if I give you numbers, you can say, hey, it's getting bigger. And it's getting bigger as you go down a group because, remember, valence electrons are going into a higher energy level. They're further away from the nucleus, therefore there's a weaker attraction, and they get bigger. Now, if you're going across a period, you have to recognize the elements are across a period. That's where the ionization energy increases or the radius decreases as you go across a period because the electrons are going into the same energy level. So therefore there's a greater attraction. That's why the atoms get smaller and the ionization energy gets larger going through. So when I say explaining, it's going to be either down a group or across the period. Okay, then again, very good worksheet. Going through it. Lots of good information in here. So make sure that you go through this and do a lot of the practicing. There's going to be a lot of concepts. You need to spend a little bit of time getting it straight. And remember when we talked about when you first see it, I would put a list, find those elements, look at increasing, decreasing, get yourself straight. Is it starting small? Is it starting big? Then look at the trend. Where is the highest? Where's the lowest? And then it's easier to put them all together as you go through. And then the last thing, like I said, I'll just give you clues. What is the largest element in the second period? I don't have the periodic table in front of me, but I believe that's lithium because the largest is going to be the element furthest to the left. What's the largest element in group 1? That would be francium if it existed. Okay, so just wanted a little bit to go through. It could be a very good test. If you choose to blow it off, it may not be as good of a good quite as great of a test. I'm going to be there Monday morning and Tuesday morning, so if you have any questions, just let me know. Anyway, have a great weekend, and I will see you on Tuesday, if not before.